Welcome to this episode of At Home with APS. Hi, my name is Mrs. Gaudette, and Mrs. Sears and I will be working with you today on several things. We'll be working first with our routine and just thinking about numbers and place value and stuff like that. Then we're going to move into a task working with addition and subtraction of unlike denominators. Ooh. We're going to get you really working and thinking about that math. Then we're going to move on into a book called The Doorbell Rang and then be playing a game. So let's start with my first activity for you says, who am I? So again, with this, we're working with numbers. And what numbers are we going to come up with? But first, you'll notice with this one is it has the digit. It keeps talking about the individual digits in my number. So we're going to have to figure that out. It's a little riddle for us. So the first one says my hundreds place digit is equal to 48 divided by 6. So I already know because I'm working with numbers. Oh, did you guys remember to have something to write with and some paper or a spiral where you're doing all your work with us? Make sure to do your work with us. Maybe pause me before I go over it. You try it out first and then check your work against mine. Again, remember, I am just doing what I call my teacher think or teacher talk. I'm working how I process through this. So you get another person's view on how they think about these problems. First thing I always do is I know I have to go to the hundreds. So I'm going to draw myself lines because I know that I have to go to 3 place values over ones, tens, and hundreds. So it said my hundreds place digit is equal to 48 divided by 6. So what is 48 divided by 6? Well, I know if I do 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And I know a lot of you guys are going, Mrs. Gaudette, I bet you just knew that fact right off the top of your head. To be honest, I actually did I went back and did it like that, thinking about what is 6 times 7, what's times. I double check myself because I'm also don't want to be on here all the time and messing up all the time either. But it's not just that. That's how I've learned the facts. And I go back and I double check myself. So it is okay to go back and double check with a fact you know for sure and then go forward or backwards from there. All right, my 100th. What are we in? We're in decimals. So I know I'm going to have a decimal here. And I know I'm going into the hundredths. So my first digit behind the decimal is my tenths. My second digit is my hundredths. Because there's always 10 different, either 10 times smaller or 10 times larger. All right, my hundredths digit is half as large as my hundreds place digit. So if this is 8, what's half of 8? 4. Thank you for calling that out. You know I like when you guys call out answers to me and help me think through this. So my third one is my tens place value is equal to 9 divided by 9, or 9 ninths. Going back to yesterday and a few days ago, 9 ninths. What is that for us? It's 1 whole. Oh my gosh, you guys. So in my tens, I'm going to put 1, because 1 whole. Then it goes my tenths place digit is 3 tenths. So if I have 3 tenths and we're out of 10, what is my number? How much do I have? It's 3. Because I have 3 out of 10, and 3 tenths is the equivalent to this place value. All right. Oh, I have thousandths. Oh my. I'm going to have to go 3 place values out to help me out here. So if I know my thousands place value is 3, this is the way we say it, 3 thousandths plus 5 thousandths. If I have 3 thousandths plus 5 thousandths, 3 plus 5, how much do I have? I have 8 thousandths. Again, remember when you're saying that, I emphasize the THS here because that just helps us know the difference between thousands with that S on the end and then the thousandths. It kind of sounds the same, but if you emphasize with your tongue between your teeth to help say that, we can see the difference between the two. All right. I don't know my ones. I am worth more than 818, but less than 820. Oh, I just did it. Did you guys catch that? I put the and in there. We got to cut the and out. 820. Well, if I'm only in the ones, so I can only think about the ones place value. So if I have 818, 820, what goes in between? 819. Is that what you guys got? 819 and 348 thousandths. All right, say that with me. Because so the last week or two, we haven't been working too much with decimals on this one with the thousands. So let's say it again. 819 and 348 thousandths. All right, so that is going to be our number of the day. So let's go ahead and look at 819,000 and, I just said it wrong, 819 and 348 thousandths. Place the digits in the correct place value chart. So I always like to start at the back. What spot is this 8 in? What place value would we put it? Would I put it in the ones? No, this doesn't go in the ones. This, you notice the ones is right next to that decimal. So it's not there. So we got to move it. So we're thinking we have tenths, hundredths, because remember, it's always 10 times smaller when we're going to the, let me get this right, to the place value. So we have tenths, hundredths, thousandths. So we have 8 thousandths, get that TH in there. Then let's go to the next number. The next digit is 4. So what would that be? Would it be in our ones again? You notice I keep wanting to go to the ones because what happens, we always try to put these number in the ones place value when it doesn't belong there. It is tenths, hundredths, so it would go in our hundredths. So we have 4 hundredths on our number. And then our 3, we have 3 tenths. All right, so let's go. And now we're going into our numbers like our digits that we had like last time. Our 9 ones, so we have 9 ones. And then in our tens, we have 1 10. So that's all we have is 1 10. And then our last one, how many hundreds do we have? We have 8 100ths. All right. A little later on, we're going to ask what is the place, what does all this mean? So be thinking about how you would write all this. So we're going to move on, and here we go. I told you it was coming. What is the value of the hundredths, thousands, hundreds, tenths, ones, tens, and hundred? Oh, that is a typo. I'm going to tell you that right now. It's just meant to be hundreds, not hundredths, because we have already done that. So I'm going to scratch that out. Ignore that. It's hundreds. So let's start with our thousandths. We said that after the decimal point, we have tenths, hundredths, then the thousandths. But how would you write that when we're talking about the value? I know I have 8 of them, but how do I write that? Is it 8 and then I write 8,000? Is that what it means for thousandths? Yeah, no, they're a lot smaller. So we can't be doing that. So it is 8 thousandths. We are showing that it is really, really, really tiny. It's not large, it's really tiny. So if you're thinking about that, remember I've been talking about money a little bit. Would you want 8,000 or 8 thousandths? That's less than a penny. Would you want less than a penny or would you want 8,000? Right? I can already hear it. So this is less than a penny. Be thinking about that. Hundredths. We have 4 hundredths. So if I have 4 hundredths, would I have 400? 400? No, I wouldn't. I would actually have what, if we were remembering what Mrs. Sears did yesterday, this place value is our pennies. How many pennies is that? It's 4 pennies. And if we write it out in our place value, it is 4 over 100 or 4 hundredths. All right, you guys, so we will finish this later on another day. Be thinking about your work, and I will make sure to come back and go over that with you. So we're going to move into our task today. We have something called leapfrog. So in the leapfrog, let's go over the information that we need to be able to answer it. These leaping frogs are playing a fraction game. They leap from lily pad to lily pad, adding up the fractions as they go. They have just 3 lily pads each. All right. Is there any information that we need to help us solve this? Well, they're playing a game. They're leaping from pad to pad. Yeah, it's good information, but we don't need that. Do we need they have just 3 lily pads each? Yeah. That is information we know. They just have, we always do that, right? They just have 3 lily pads each. So I'm going to circle that because that's information I need to remember. When they have counted up to 1 hole and no more, they can reach the island in the center of the lake. Again, is there any information that we need to help solve this, or any digits, any numbers that would help us solve this? When they have counted up to 1 hole and no more, they can reach an island in the center of the lake. Is that important? It's the 1 hole. We are being told right here that has to equal 1 hole, no more. And then we know they're going to reach an island. In a second, you will see the picture for the island. Number 1 says, complete the lily pad fractions so that these 5 frogs can get to the island. Write your answers on the empty lily pads. What are we being asked to do? Complete it, right? Complete the lily pad fractions so they can get to that. And then we're asked to write your answers. Again, is there any numbers here? No. We still haven't gotten any numbers except for the 1 hole. So let's look at, so here's the island. We know that frog 1 starts here and has to hop, 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 then get to the island. They can't just hop straight to the island. Wouldn't that have been so much easier? So we're asked, based upon the information we just had, is what would be this 3rd number? So let me start with frog 1. I know I have a half, and I know I have a 4th, And then I know I have some unknown number. I don't know that number. That's the number I'm going to have to figure out. That has to equal 1 whole. So, because I have to get to a total of 1 whole, what could I do with the fractions that I already have to help me out? Right? I'm going to have to add them. But I have 1/2 plus 1/4, and I'm going to have to figure that out. Ooh, I think I'm trying to trick us up this time, right? Can I just do 1 plus 1 equals 2, and then 2 plus 4 equals 6? Can I do that? No. If you remember from yesterday, we talked about that the denominator, we're not allowed to add those because that's telling us how many pieces are in the whole. All right, so let me undo that. We didn't like that. What else could I do? I hear some of you guys, right? We have to find what we call a common denominator. And what that means is I need a denominator, which is the bottom number of the fraction. I need it to be the same number so that I can find out how many's in my numerator. All right, so I am looking at a 2 and a 4. So now I'm going to go back down into my multiples. You guys remember what multiples are? Right, those are the numbers, 1, 2, almost like you're counting, or numbers that you can multiply by. If I count by 2s, I count by 4s. What do they have a number in common? 2 and 4. Well, I know if I'm looking at 2, 4 cannot go smaller. 4 is 4. But can 2 go bigger? Can 2 go into 4? Evenly, it can, right? It can go evenly into 4. So 4 works for 2. Does 4 work for 4? Yeah. So I'm going to go ahead and put my 4 underneath it. Now here's where our true work comes in. My 2, I did something to the 2 to get 4. Thinking about multiples, what did I do to my 2 to get to 4? I multiplied by 2. 2 times 2 is 4. So I'm going to put just a little times 2 on the outside so that you guys can see that that's what I'm working with. 2 times 2 is 4. What is 1 times 2? 2. Did I have to do anything to the 4 to get 4? No, I can just bring my number down. So now I have a common denominator. Now I'm allowed to add. So I have my 4 in the denominator. What is 2 plus 1? 3. Okay. So I know a 1/2 plus a 1/4 is 3/4. But I got to get to 1 whole to get to the island. So what can I add to 3/4 to get to a whole? All right, let's go back. What is my whole in a fraction? My 1 whole. If I have 4 as my denominator, if I was to take up the whole 4 pieces, how many would I have in the numerator? I would have 4 in the numerator and in the denominator. So 1 whole equals 4/4. So how do I get from 3/4 to 4/4? 1/4. So I can put on my lily pad 1/4. So I know a 1/2 plus a 1/4 plus a 1/4 equals 1 whole. And some of you may have remembered from the work that we did with Miss Sears and some of my work that we knew 1/4 and 1/4, 2 of them together make a 1/2. Some of you may have said, Mrs. Gaudette, I knew that way before you got that answer. Perfect. Remember, there's multiple ways to get this. I'm just showing you one way. All right, so let's go ahead and look at frog 2. Ooh, frog 2 has 3/6 and 1/3. And then we have an unknown lily pad to equal 1 whole. All righty. Again, we have to look at our denominators. Can we add? 3 plus 1 is 4. 6 plus 3 is 9. 4/9. No, that's not going to work for us. I'm going back over the academic vocabulary. We need to find a common denominator, a denominator that they both have in common. So let's look at 6 and 3 and think about our multiples. If I was to count by 3, I'd say 3, 6, 9, 12. Okay. If I was to count by 6, 6, 12. Was there any numbers they had in common when we counted out those? Did some of you say 12? Because I ended in 12 for both of them. 12 would work. You're right, it is a common denominator. Is it the smallest one to make the least work we have to do? No. The smallest one was 6. That was perfect for us. So I'm going to go ahead and use 6 as my denominator. Did I do anything to this 6? Nope, I left it alone. So I'm just going to bring down my 3. What did I do to this 3 to get to 6? I multiplied by 2. So we have to do the same thing to the numerator. So we know 3 times 2 is 6. So what is 1 times 2? 2. And what does that equal for us? I did that, and look at it, took up my whole spot where I was doing my work. Okay. Well, I have the same denominator, so I can bring it over. Now I can add my numerators. What's 3 plus 2? 5. All right, now this is the big question. What is 1 whole when I have 6? Yeah, if I have 6 pieces, if I'm saying I have all those pieces, I have 6, thank you. So if I needed to get to 5/6 to 6/6, how many 6 would I have left? I would need to do 1/6. Now, you guys, you could have done it like this. You could have said, I have 6/6 minus 5/6. So I did a lot of math in my head that I didn't even write down, that you were doing a lot of computation in there. So, yeah, think about that. Sometimes it's nice to do some mental math. I could have just done 6 minus 5 is 1. So this was actually a 2 steps, only showing one of the steps. But it's okay. Sometimes it's nice, right, to do that mental math and say, yes, I knew it. Sometimes I have to write it down, but sometimes it's nice to have that. So let's go ahead and go into frog 3. I have 3/5, and I know I'm going to add that 1/10, and then I know I'm going to have some unknown to equal 1 whole. All right, do you remember what our first step is? It's to add straight across, both top and bottom, right? Nope, we can't do that. What we have to do is find that common denominator. So let's go to our multiples. We have 5 and 10. So I have 5, 10, 15, 20. Then I have my 10. 10, 20. So what one would we want to use? Because you guys probably heard those numbers we had in common. Did we have 5 in common? You're right. No, we did not. Did we have 10 in common? Yeah, we did. So we're going to go ahead and put those 10 on as our denominator. We could have used 20. You're right. We could have. And that was fine. It just would have been a little bit more work for us. All right, so if we have here 10s, Did I do anything to this 10? And I'm putting the second 10 and to get to that 10? No. So we can just bring that 1 down. What did I do to this 5 to get to 10? Some of you could say, well, you added 5. You're right. But when we're working with this, we're always working with multiplication and division when we're in our multiples. So I know that what I did to this fraction is I multiplied by 2. So 5 multiplied by 2 is 10. So 3 multiplied by 2 is 6. Then we can go ahead and add. I know I'm going to have a denominator of 10 because we don't add straight across. Remember, we still have the same number of pieces that the whole was cut into, so we can't change that. Then we add the numerator. 6 plus 1 is 7. All right, now we got to figure out what that last fraction is. So thinking about that, we have tenths, right? Tenths, thank you. We have tenths as our denominator. So I know for my 1 whole, I'm going to have tenths. So what would my numerator be if I had all of those 1 wholes? It'd be 10. So my question to you is, I know my denominator is going to be 10 because we're working with tenths. So what did I do to the 7 to get to 10? 3, right? We have 3 tenths. So today we have worked on frog 1, frog 2, and frog 3. Go ahead and try out frog 4 and 5 and see what you get as that third step to the lily pad. Now we're going to move into an awesome book called The Doorbell Rang that Mrs. Sears will read.
I'll get my chair over here. And we'll also get this off of there. And we'll come to it in just a minute. All right, so we're going to read a book today. How many of you have ever had somebody at home, maybe it's a parent, maybe it's an older sibling, that has made some fresh baked cookies? Have you thought about like how many cookies you could get depending upon the number of people in your family, or maybe the amount of people who might be in your house? Yeah, this book is about that today. And it makes me think like I want to make some fresh baked cookies so that I can go home and share with my family. So I'm going to read the book for you today. I'm going to have to get my glasses on. So this book is called The Doorbell Rang by Pat Hutchins, and it is by Green Willow Books of New York. All right. I've made some cookies for tea, said Ma. Good, said Victoria and Sam. We're starving. Share them between yourselves, said Ma. I made plenty. Ooh, just 2 of them. It looks like there's a huge plate of cookies there. That's 6 each, said Sam and Victoria. They look as good as Grandma's, said Victoria. They smell as good as Grandma's, said Sam. No one makes cookies like Grandma, said Ma, as the doorbell rang. Uh-oh, I think they're going to have to share those cookies. It was Tom and Hannah from next door. Come in, said Ma. You can share the cookies. Well, there was 2 of them before, and now there's 4 of them. And I don't know if we ever figured out how many cookies they had to share yet. But those cookies they're not getting to have as many as maybe they wanted originally, huh? That's 3 each, said Sam and Victoria. They smell as good as your grandma's, said Tom. And they look as good, said Hannah. Wonder, Grandma must really make some good cookies, but Ma seems to be doing a good job. No one makes cookies like Grandma, Ma said, as the doorbell rang. Oh no, are there more people? Who is it now? It was Peter and his little brother. Come in, said Ma. You can share the cookies. 2 more people and they're having to share the cookies? Wow, 6 people now and they're sharing those cookies. That's 2 each, said Victoria and Sam. They look as good as your grandma's, said Peter, and smell as good. It's making me hungry. Nobody makes cookies like Grandma, said Ma as the doorbell rang. How many more people could possibly come over? You've got 6 people now. It was Joy and Simon with their 4 cousins. So let's see, Joy, Simon, that's 2, and 4 cousins, that's 6 more on top of already who's there in the house. Come on in, said Ma. You can share the cookies. Ooh, how many do you think they're all gonna get? Let's see. That's 1 each, said Sam and Victoria. They smell as good as your grandma's, said Joy, and they look just as good, said Simon. No one makes cookies like Grandma, said Ma as the doorbell rang. Do you think there's more people? Wow, right now they're at 1 each, and that's kind of slim pickings. I don't know, are they going to have to start making fractions like we did over here so they can share? And rang. Maybe they're wondering, what are we going to do? How many more people are coming? Oh dear, said Ma, as the children stared at the cookies on their plate. Perhaps you'd better eat them before we open the door. Well, maybe they're worried that they're not going to get enough or have a whole cookie to share. They're going to have to start sharing pieces of their cookie. Well, we'll wait, said Sam. Well, he seems like he wants to help and share. They're going to wait and see who's at the door. I wonder who's at the door. It was Grandma with an enormous tray of cookies. Yay, they don't have to share. They still are going to get their whole cookie, right? How nice to have so many friends to share them, said Grandma. It's a good thing I made a lot. That was kind of a cute little book, huh? So they were sharing cookies. Let's go back and let's kind of look into the story and see if we can figure out how many cookies were they sharing. Remember, if we looked at the very beginning of the book and we were saying that Ma first brought out the plate of cookies, how many people were at the table? 2 people were at the table. It was Sam and Victoria. Did we have any clues on here to tell us how many cookies were on the plate? We might be able to count and see, but it's actually this next page that kind of tells us a little bit of information. It says that's 6 each. So I thought what we could do is we can work that out. And then I also have some actual cookies. And this is one thing I was trying to do maybe yesterday when we were really talking about remainders. We had a game about remainders race. So it's really good if you need something to count or if you need something visible for you to be able to manipulate. You could use things like that to help you figure out what we're working on. All right, so I'm going to go ahead and move this, get to a clean page. Boy, Miss Gaudette, you had a lot of stuff on there. So how many cookies did we say that they started out with? Oh, wait, we haven't figured that out. But we know we have Sam and Victoria. So I'm going to draw a plate. So that one's for Sam, and that one's for Victoria. And how many cookies was the clue? It said that they got 6 each when they got there. So if I put 1 cookie here, oh, it looks like a happy face. 2 cookies here, 3 cookies, 4, 5, 6 cookies. But they got 2 cookies or 6 cookies each. So I need to do the same for Miss Victoria here. So 6, 7, 8, 9, 10, 11, 12 cookies. That's a dozen. So another way to look at that is 6 times 2 is 12. But let's do a division sentence because this is what we're going to want to know, right? 12 divided by how many people? 2 people would equal what? How many cookies did they get each? 6 cookies. Wow. So you mean I could also think about multiplication like division? And division like multiplication? That could kind of help me figure it out. Remember when we're doing that, this is our dividend. This is the number, the big number that we're breaking apart. We're trying to divide up. This 2 is our divisor. That's the number we're making the equal shares around for it. And this 6 is our quotient. Okay, let's go a little bit further into that. Let's see if we can figure out the next part of the story. I always think I do this. Nope, I want that one gone. All right. So who came to the door next? Oh, it was Tom and Hannah from next door. So now how many people do we have? And actually, I'm gonna forward this on because we have a visual that can kind of help us with this, but I want to see if maybe we can translate this into our table. So we had 2 people at the table. That was Sam and Victoria. Get that on there. 2 people at the table. How many cookies did each person get? We had 6 cookies that they got each. Remember, we were using our math sentence. We could do either 6 times 2, which gave us 12, or we could do our 12 divided by, I don't think I make those dark enough. 12 divided by 2 gave us, how many did they get each? 6. And this was one thing that we were talking about with our remainder yesterday. Was there any left over? Did they have any extra cookies to spare? No, they had no extra cookies to spare. So now who came over to the house? We had Tom and Hannah. How many people? 4 people. At least sitting at the table. Mom was still, remember, it looks like she was sweeping the floor or doing something. But there was 4 kids at the table when Tom and Hannah came, as well as Sam and Victoria. How many cookies do you think they're going to get each? Well, I could go back and I could do my example and see. I could make those 4 circles. And I could start to see how many cookies would each one of them get. I could go, here, you get 1 cookie, you get 1 cookie, you get 1 cookie. This is not hard enough on there. Yeah. Okay. There we go. You get 1 cookie each, so that's 4 cookies. I could do that again. So 5, 6, 7. I really am like 8, 9, 10, 11, 12 cookies. We knew they had 12 cookies. So how many did they get each? If I look at how many's in my circle, 3 cookies each. Let's write a sentence for that. We could say 4 kids. How many cookies? 3 cookies each. Gives us how many cookies in all? 12 cookies. What about a division sentence? 12. How many kids divided by? 4 and 3 cookies. Any left over? None. All right. Next one. And I'm not going to draw it out this time because it seems like my little finger doesn't like to work as well as it on there. But we had, who came over next? It was Tom and Hannah. Was that their names? Oh, no, it was Peter and his little brother. Okay, so that's now how many people? We have Sam and Victoria. We have Tom and Hannah. And we have Peter and his little brother. 6 people, right? Okay, Ooh, it's kind of interesting because I'm starting to see some numbers that are in common here. Maybe this might be a clue as to how this works. Do you want me to use a pen? Would that work better? Okay, we'll try it. So we have 6 kids. We can do 6 circles. And we can do, again, just kind of do an equal sharing. You know, I give one to you. I give one to each one of them. So I've already given out how many? 6 of them. If I give out another one to each person, they're each going to have how many? 2, right? So how many cookies does each person get? Let's look at our plate. They got 2 cookies each, right? All right, division sentence, here we go. I think we're gonna see some commonalities up here. This time, I had how many, I should have done it the opposite way. This time, I had really 6 kids. So I'm gonna do it this way. We had 2 cookies each. How many kids? 6 kids. You're kind of gonna start to see some differences or some similarities in the way that I did that. 6 kids, they each got 2 each. How many total? 12. So if we did 12 divided by those 6 kids, we had 2 cookies each. Any left over? None left over. We're working really well with that denominator right now. We're having to be equal shares on everything. All right, the last part of the story, who came? Joy and Simon, right? Joy and Simon, they brought 4 cousins with them. So we had 6 with Joy and Simon makes 8. 12 people were in the house at the last time. If we had 12 cookies and 12 people, how many cookies do you think we would get? I kind of want to put that like into a fraction like Miss Gaudette did. If I had 12 cookies in all, like in my denominator, and I had 12 people each wanting a cookie, how many cookies would each person get? 1 whole cookie, right? All right, so let's write that division sentence. And if you kind of think about fractions, it's almost like you're dividing. We have 12 pieces or 12 parts. 12 kids are gonna each get a cookie. How many cookies in all? 1 cookie. Any left over? Nah, that's it. Okay, so I do have some extra problems for you guys to do at home if you have the time to do that. And I'll go ahead and just show you. Those will be available on our resources for you if you would like to. There is at the end of the story, if you remember, Grandma comes with a whole big batch of cookies. And you can decide how many cookies Grandma brought. And I want you to write a problem for yourself and decide how many children you're going to divide those cookies in between with. And remember, you can cut out the little cookies if you need to see how many are left over. Maybe you'll have a remainder. If you have a remainder, that's going to be kind of some interesting math to see how that works out. We're going to get ready to do a game. I'm going to bring Miss Gaudette in to play the game with us. And if you've watched this before, we've done something called headbands. Well, we have a little better technology now. So instead of us having like our actual piece of paper and we're like not able to see the word, the one that's going to be guessing the word is going to be facing you. And me, I'm going to be giving the clues to help figure out the word. You're going to be listening to me and see if our Miss Gaudette can guess what I'm describing. These are all vocabulary words that we have been talking about for the past couple of weeks, all right? So I'm gonna start because I don't want her to see the words. You gotta be facing the camera, okay? And she's gonna do this to me too. And I say this is like a minute to win it because I really wanna be able to like explain how how fast I could understand these vocabulary terms, but it's kind of like taboo in the sense that I got to not say some of the words. So hopefully I don't give it away.
Or parts of the words.
Or parts of the words. I know some of them are going to be hard. All right, are you ready? Let's go. Oh, okay. So this is the part of a fraction that's on the top.
Numerator.
Okay, this is the part of a fraction that's on the bottom.
Denominator.
Okay, this is I don't know if I can say that word again. This has a 1 in the numerator when it's a fraction. I kind of have to say that word in there.
The unit fraction.
The unit fraction. And then this one would have anything other than a 1 in it if it was a fraction.
A common fraction?
It could also be like maybe people drink their tea really with their finger, and it's
proper.
It's very
proper fraction.
That's the only thing. I'm trying not to. Okay, your turn. You ready? I'm not going to look, but you can click away.
All right.
If it's easier for her. Did I do it in less than a minute? I hope I did.
All right. So when you have a number, it's the individual numbers in there. So the ones place value has an 8. That would be a
digit.
Okay. So this is multiple digits put together. It is a
okay. It's like a string of digits, like a number?
Number.
Okay.
When you're writing out a number and you actually write, like my example was 819, and that is the way you write it, what is that called?
So you write it like out, is that standard form?
Yep.
Okay.
Oh my gosh, she's good, guys. All right, now you actually, when you write it out, a number, 819, it's the way you say it. What is that?
The way you say it?
The way you say it is how you write it.
So is it like expanded?
No. So you, if I was to 819, I would actually spell out 800.
Written form?
Written form, there we go.
Okay.
All right, the next one, 819, you would write it out as 800 plus 10 plus
expanded
9.
form.
All right.
That's the one it is. That's the one it is. Okay. Oh, yay. Well, you had 5 words. Wow. Good job. Let's do one more. And, we were just talking about this. Let's see if she can remember it. Okay, so when we're thinking about division sentences, this is the number that we are breaking apart, the big number.
So it's not the dividend. That's what
yes, that is the dividend.
All right. Well, you could tell I was about to get those.
This is the number that we break it apart by.
The divisor.
Yes, and this is the answer that we get in the equal shares.
Quotient.
Okay, or sometimes not equal shares, but well, it would be in the equal shares that we would get. This is what's left over.
Remainder.
Yay! Woo! Good done. Whoop whoop. Okay, we're gonna move on. We just have a quick game for you today. This one is called the prime time game. And we got it actually off of U Cubed. And let's explain how to do this because we are gonna have to color certain parts of the square. We have our spinner back. Remember that from yesterday? That was really fun. You could also use 2 dice to do this. Okay, so what's gonna happen is you're gonna roll the spinner. If you roll onto a 1 or a 2, and this is where the prime comes in, you're gonna have to fill in all the prime numbers on the 100 chart, okay? Or as many as you can think of. If you get a 3, well, I guess a 3 would be also a prime number too. Wow, ooh, this could be tricky. We might have to roll twice on the spinner. That might be what we need to do. So if we roll twice on the spinner and we actually could add those 2 numbers together, that might help us figure out how to do this a little bit better, okay? So we'll roll twice on the spinner. What's gonna happen is when we roll twice on the spinner, we're gonna add those 2 digits together. We're gonna add those, the sum of those 2 numbers that we're gonna get together, and we're gonna have to color in all the multiples on our board for that, okay? So let's say I got a 2 and a 1. So I would have to color in everything that has a multiple of 3. So I can do 3, 6, 9, 12.
All the way up to 100.
All the way up to the 100.
Oh, my.
And I want to pick a color so that at the very end, I could see, how many squares I had. Another variation, and I'll put it to Miss Gaudette if she wants to do it. So let's say I did that 3, 6, 9, all the way on up. Maybe the last multiple that I know that's going to be with a 3 is going to be a 99. That 99 becomes my score, and we can add our sum to see who gets to the highest at the very end.
We can do that.
Would that be easier? There's a couple of variations, but I know we only have a few minutes left, so we want to get right to the game, okay? But if you did roll, because you did a 1 and a 1, if you rolled a 2, you do have to do those prime numbers. So the prime numbers, you're going to have to know a little bit about prime numbers. It's going to help if you know a little bit about how those prime numbers. And we haven't talked about a prime number before. A prime number is a number that can only have a factor of 1 and that number. Okay, so when we say like 2 can only have a 1 and a 2 as its factors. The only way it's going to happen. Like a 2 could be part of a factor of many multiple other numbers. Okay, are you ready to begin? Great. I'm going to let you start, and what color do you like?
I'm always red.
You're always red. I'm going to give you red.
So I have a 2.
All right, she's got to add those 2 numbers.
And a 9. So
Ooh.
2 and 9 is 11. Mm-hmm. So I find all the multiples of 11. All right. So
and then you're going to add your score on the very last one.
11, 22,
Ooh.
33, 44.
Ooh, I see
55,
a pattern already.
66, 77, 88, 99. Ooh.
Okay.
All right,
so she's got 99 right now. She's probably could win if I take a little bit longer. She's going to have the higher score, right?
4.
Okay, 4. And I'm going to add these 2.
And
now if she gets a 7, then I can't do anything
4
with
and
that. 8. Okay, 4 and 8 is 12, right? Ooh, we just did a bunch of 12 stuff too, because that was a dozen. So I can do 12. Let me change my color.
Keep it my color.
No, I'm not going to do that. Let's see, 12. Oh, this time it doesn't work with that pattern. 24, 12 plus 12, 36. It almost like it skips. 36, 48, 60. What's next? 60, 72. Wow, that really jumped over. 84, 96. All right, she is beating me.
So really fast while I'm spinning this, the object of the game is to get the most points?
The most points.
Okay.
Or to color, if we had started a little differently, we would have colored in all of the squares. And so whoever had the most squares to color in.
6 and 7 is 13. All right, so if I have 13.
I did change it for you.
Oh, thank you.
Okay,
13,
and we have I think I'm going to have one more turn
26.
So I really got to roll a good number. Come on, make me roll
39,
a good number.
39, 49.
So what are you doing with your math? Because you just said 39, 49.
I was trying to add 13. And I was like, well, if I add 10 and then add 3, it will help me out. So 39 plus 10 is 49. Add 3, 49. 50, 51, 52.
And again, you could have counters when you're doing this to play kind of with the numbers.
65. Now I'm guessing, to be honest. I'm going over 3. 78. Plus 10 is 88. 89, 88, 89, 90,
I think
91.
we're going to have to wrap up here in just a
91.
minute. Okay, so you're at 91. Okay. Do you want to roll? We've got 1 minute left, really. So I think you're going to have to
see.
end.
Go ahead, talk.
Okay, I'm going to keep talking while she's going to see where I would have ended up with. But we've really had a good time today where we worked on a number of the day and it had a decimal in it. Then we played a cool game, Leapfrog. We did an awesome book about division, The Doorbell Rang. We also played another vocabulary game called Minute to Win It. And finally, this primetime game. We had a lot of fun doing a lot of different math for you guys today. And we want to thank you for joining us with At Home at APS. We hope that you have a wonderful day, and we'll see you again sometime.
Bye, everyone. By the way, she would have had 9, all the multiples of 9.
Oh.
Have a great afternoon.